Chemistry. Today we're going to be looking at oxygen, part 1. We'll look at the following outline: introduction to oxygen, laboratory preparation of oxygen, industrial preparation of oxygen, physical properties, and finally uses of oxygen. Introduction. Oxygen is a non-metallic element that exists in group 6 of the periodic table. It is a diatomic molecule represented as O2. Okay? O2. So that's how we write oxygen molecule. It is essential for the combustion of substance, makes substance to burn, and it is a major constituent of all acids. Lavoisier named it oxygen, meaning acid producer. So most acid has oxygen in it. Oxygen combines with most nonmetals to form acidic oxides, which dissolves in water to form an acid. Examples of nonmetals are sulfur, carbon, phosphorus, etc. Any of them can react with oxygen, like carbon plus oxygen produces carbon 4 oxide, CO2. And CO2 is an acid anhydride or acid oxide. Okay? When this acid oxide reacts with water, which is H2O, okay, what we have is an acid. In this case, H2CO3, a weak acid. So all acids contains oxygen. Oxygen is the most important element on Earth. It occurs in nature in both the free and the combined state. It can be free, it can be combined also. All right? The free oxygen makes up about 21% by volume of the air and about 33% by volume of dissolved air. In the combined form, it is present in trioxocarbonate 4, oxides of metal and non-metals. Preparation of oxygen. First, we look at the laboratory preparation of oxygen. Oxygen is produced when potassium trioxochlorate 5 decomposes in the presence of a manganese 4 oxide which acts as a catalyst. Alright? The manganese 4 oxide does not react with it, it is just present to make the reaction to be faster. The reaction is shown below. So potassium trioxochlorate 5, which is KClO3, right, breaks down to give us KCl plus oxygen. So oxygen is a gas, KCl is a solid. Manganese 4 oxide is present as a catalyst to speed up the reaction. Industrial preparation of oxygen. Industrially, oxygen can be prepared from the fractional distillation of liquid air. Okay? Now, air in the gaseous form is first passed through caustic soda, which is sodium hydroxide, to remove carbon 4 oxide, that's CO2. First pass air through caustic soda to remove carbon 4 oxide. Let's look at it this way. Air, okay, passes through caustic soda, which is sodium hydroxide. After passing through the sodium hydroxide, what remains and what is removed is CO2. Okay, so what remains now becomes oxygen and nitrogen. those two things will now be there in large quantity. Now, the purified air, the purified air, meaning that CO2 has been removed, that is rich in oxygen and nitrogen, is then liquefied. You convert it to liquid by cooling it. All right, the nitrogen and oxygen is liquefied by cooling. So this liquid air is subject to fractional distillation as shown. So the liquid air passes through a fractionating column and then releases nitrogen gas, all right, first, and then finally releases oxygen gas. Okay, the nitrogen gas on distillation, which has the lower boiling point, evolves at minus 196 degrees Celsius, leaving behind a liquid very rich in oxygen. Of course, that's the oxygen that we need. So what do we do with the oxygen? The oxygen obtained is dried, compressed, and stored in steel cylinders under a pressure of about 100 atmosphere. Physical properties. Number one, oxygen is a colourless, odourless, and tasteless gas. Okay. Number two, it is neutral to moist litmus paper. Moist litmus paper is litmus paper that have been damped with water. Okay. Number three, it is slightly soluble in water. Slightly soluble in water, not too soluble. Number four, it is approximately 1.1 times denser than air. And then finally, number five, it liquefies at minus 183 and solidifies at minus 225 degrees Celsius. Finally, in this video, we look at the uses of oxygen. Number one, oxygen is required for respiration. So every man takes in oxygen. It is very important for humans. Number two, it is used in oxy-acetylene flame for cutting metal. The flame comprises of oxygen and acetylene combined together for cutting metals. It is used as a component of fuels for rockets. So it's present in the fuel of rockets. Okay, number four, it is used in the manufacture of steel, tetraoxosulfate 6 acid, trioxonitrate 5 acid, and ethanoic acid. Finally, number five, it is used in the removal of impurities like carbon, sulfur, and phosphorus from pig iron production. Okay, thank you for watching this video. Ensure to subscribe.